I am mathematics, but don't think of me as just cold, abstract numbers. Let me tell you a story. It's a very human story about ambition, a bitter rivalry, and a discovery that completely changed the way you see the world.
You might think my stories begin in quiet libraries with someone pondering an equation, but not this one. Oh no, this one starts with a bombshell, a vicious public accusation that lit the fuse on one of the greatest intellectual battles in history. Plagiarism, that was the charge, a theft of pure genius. It was an explosive claim, and just like that, two of the greatest minds of the age and their home countries were at war, a war that would last for decades. So let's meet our fighters. In one corner, you have Isaac Newton, the giant of English science, a man who was secretive, solitary, intensely focused. And in the other corner, Gottfried Wilhelm Leibniz, a German diplomat, a true Renaissance man, whose mind touched everything and who believed in working together. So what on earth were they fighting over? What idea could possibly be worth all this trouble? Well, it was the solution to a problem that had humans stumped for thousands of years. And honestly, it was a lock that even I didn't have the key for yet. Think about it. For centuries, I was great at things that stood still. Measuring a field, counting coins, no problem. But the real world, it doesn't stand still. It's constantly moving, flowing, changing. And I didn't really have the words for that. And that was the prize. Not just a new formula. It was a whole new language, a language for motion itself, a way to finally describe the universe as it really is in all its dynamic glory. The breakthrough, the version of this new language that would actually take over the world, well, it came from the person you'd least expect, Leibniz, the outsider. And he saw it not just as a math problem, but as a language problem. And here's the kind of crazy part. Leibniz wasn't even really a mathematician in the way you'd think. He was a diplomat, a philosopher, an inventor. His big dream was a universal language for all human thought. He believed the right symbols could make any complex problem simple. So what was his brilliant idea? He took these weird, almost mystical things called infinitesimals. They're quantities so small they're basically zero, but not quite. Critics mocked them, called them ghosts, but Leibniz, he saw their hidden power. And look at how elegant this is. You want to find the slope of a curve at some point? Just imagine 2 points on it that are infinitely close. The tiny horizontal change between them is dx. The tiny vertical change is dy. The slope? Well, it's just dy divided by dx. Suddenly, a really hard geometry problem becomes simple algebra. The notation does all the work for you. Okay, so to be fair, Newton had figured this stuff out too. He called his method fluxions, but his approach was, well, a little clunky. And most importantly, he kept it a secret for decades. Leibniz, on the other hand, designed his system to be shared. And this table just lays it all out. You see, Newton's method was personal, built for himself. Leibniz's was symbolic, built for collaboration. And that's the key. Newton might have discovered it first, but Leibniz published it first. He sent his idea out into the world for other people to use and build on. So in the end, there was a winner. Not the man, but the method. History chose Leibniz's tools because, frankly, they were just better, more intuitive, more flexible, and way easier for printers to typeset. It was a language designed for a community, not just for a single genius working alone. See, Leibniz didn't just solve a puzzle. He gave humanity a new voice, a new way to speak my language. That little squiggly integral sign and the D for difference, those were his immortal gift, a gift that changed absolutely everything. But, and with humans, there's almost always a but, this incredible gift came at a terrible personal cost. The argument over who was first wasn't some polite academic debate. No, it got ugly. It became a bitter, poisonous, international feud. This thing dragged on for years. It turned into England versus Germany. And get this, it got so bad that Newton, as president of the Royal Society, the biggest science club in England, oversaw a supposedly impartial investigation that he secretly helped write himself, just to prove he was right and Leibniz was a thief. You can't make this stuff up. And who won this war? Nobody. Absolutely nobody. In fact, British mathematics basically shot itself in the foot.
Out of sheer national pride, they refused to use Leibniz's superior tools. And because of that, they fell behind the rest of Europe for over 100 years. It slowed me down. It hurt everyone.
The truth of it is so simple, it's almost heartbreaking. They both discovered it, on their own. It should have been a party, a huge celebration that a great idea had finally arrived. But instead, it turned into one of the saddest, most pointless fights in the history of ideas.
So, in the end, Newton died a national hero in England. He got the big state funeral, all the honors. And Leibniz, the man who gave me the modern universal language that we all use today, he died pretty much alone, disgraced, and bitter.
Someone who was actually at his funeral wrote that he was buried more like a robber than what he really was, the ornament of his country. Just imagine that. The ugly feud had so poisoned people's minds that his own colleagues turned their backs on him. But here is the most important lesson you've got to remember. The squabbles of humans, they fade. What lasts? The tools, the ideas. Their personal fight was just noise. The real victory, the real story, was the incredible gift they gave to the world. And that leaves all of us with a really fascinating question. The next time you see these symbols, dy, dx, or that integral sign, remember they are so much more than just math. They are the scars of a bitter war. They're a monument to a brilliant mind. And they're proof of the timeless power of a perfect language. It really makes you wonder, what impossible problem is out there right now, just waiting for someone to invent the right words?